Hi everyone, so welcome back to my GATE crash course on data science and AI, and we are talking about probability, right? So this is going to be lecture number 5. Okay, already we have given around you can say 15 sessions on GATE data science crash course, right? So in that 7 sessions were on permutation and combination, and this is going to be fifth session on probability. So I think many of you might have got some a kind of insight which might help you, score complete marks from this topic. So in this session, what I'm supposed to discuss here is I'll talk about problem based on Bayes theorem as well as the total probability theorem, because last time I covered the theory, but because of paucity of time, I was not able to start with the problem, right? So today we will take a look at the problem, and we have to identify that where we have to use Bayes theorem and where we have to use total probability theorem. That is very important to identify, right? So let's begin the session here, guys. So I think many of you can understand this. Okay. So here the very first question that I will take here is so that you guys can understand the situation, right? So this session is on TPT as well as you can say TPT and Bayes theorem. Okay. The the theory behind this already I have discussed using the description, sequential description, or you can say a tree diagram. So you guys can watch that session, right? So let us take one problem here and try to understand it, right? So suppose a box contains 3 coins. There is one box, you can say, that contains 3 coins, right? A box, you can say, contain 3 coins. Okay. If there is a box which contains 3 coins, okay, so there are three types of coin basically. One coin is fair, okay, fair in the sense both side is like one side is head, other side is tail, right? So you can say that that is going to be fair coin. I mean that coin is not biased, okay. And the second coin is nothing but a doubly headed coin, means both side has got head only. So if you're going to toss the coin, so you're going to get head only, right? You're not going to get any other outcome, right? So that you have to keep in mind. So a box contains 3 coins, right? One coin is fair. Okay, you can say that one coin is fair. Okay, so each and every line you have to understand, right? One coin is fair. One coin is doubly headed. Okay, doubly, double headed, you can say doubly headed, and uh, and one coin is weighted one, right? One coin is weighted, and one coin is weighted, and they have given the probability also, right? If some sort of a coin has got, like some sort of a weight, one side of the weight is gonna be very high. You can say heavy dough, okay, like the weight is heavy, okay. So if you're going to toss it, so you're going to get the same, right? Okay. So what is the probability of getting head in this case? They have mentioned already. So probability of getting head is 1 by 3 in this case. Otherwise, if the coin is, the fair coin, so probability of getting head is always 1 by 2. The probability of getting tail is always 1 by 2, right? So these things you have to keep in mind, right? So if you have played with some sort of played with the coin, right? If you have done some sort of a biasing with the coin, right? So the situation is not equally likely, that you can say, right? Okay, so you consider one box that has got one fair coin, one doubly headed coin, and one coin which is having a weight toward, you can say, which is weighted, you can say. So the probability of getting head is nothing but 1 by 3. So probability of getting tail you can find out. Now the experiment will start. You see, a coin is selected at random. What? A coin, you can say, a coin is selected at random. Okay. A coin is selected at random. This is the experiment they have mentioned. A coin is selected at random, okay, and then tossed, you can, and tossed. Okay. So what they are asking now is find the probability that head appears. What? Find the probability that probability that that, okay, head appears. Okay, head appears. Now the question is, in this kind of a problem, what we have to use? Okay, whether we have to use Bayes theorem or TPT, right? Total probability theorem. So in this question, we have to use total probability theorem, because they're asking find the probability that head appears. Whatever you do, whether you take a coin, fair coin or doubly headed coin or weighted coin, okay, you should always get what? You should always get head. Okay, so probability of getting head happening, all the happening, whatever events occur, right? So there are three events basically, right? You can see here, let me solve this question using the tree diagram that I have discussed. Okay, so in this question, what you have to do, you have to use total probability theorem. You see, find the probability that head appears. So it is fixed. Okay, it is fixed that head will appear. Okay, but before that, there are some initial beliefs, right? So you can say that uh, there are three coins. Okay, in the box there are three coins, right? Let me take these three coins. Suppose this is a box and there are three coins: first coin, second coin, third coin, right? The first is fair, this is doubly headed, and this is weighted, you can say WC, or this is FC, you can say, right? So first of all, what you will do, you will take three coins from the box. Okay, so how many ways are there? You can take three coins. So what will be the probability, right? That is very important to keep in mind, right? So suppose you started, initial belief is what? Initial belief is you will take coin first. Okay, you're going to take coin from the box. Okay, suppose this is a box and you're going to take coin. So you can take fair coin, you can take doubly headed, or you can take WC, weighted coin, right? So what will be the probability of picking up coin from the box? That is 1 by 3, 1 by 3, and 1 by 3. Okay, I think this is clear for all, right? 1 by 3, 1 by 3, 1 by 3. Okay, so these are the initial beliefs, right? These are the initial belief, right? Next is what? Next you have to toss the coin, right? Tossing a coin, so that will become the conditional probability here, right? Conditional. Why? Because first of all, you are taking up the coin, you are picking the coin from the box, right? And then you are performing the experiment again, right? So it is one kind of experiment, you can say, picking up the coin from the box, and then this event already has occurred. Now if you are going to toss the coin, right, so you should get always what? Head, right? So if you're going to toss the coin, so suppose you have tossed it, right? Tossed, and what you have to get here is you have to get head. Now they are asking what is the probability that we will get head, right? So if you suppose you pick up fair coin, okay, so what will be the branch probability of this, right? You can find out, right? If it is a fair coin, right? If it is a fair coin and if you're going to toss it, so you will get always 1 by 2. Okay, the probability of getting head is 1 by 2, right? What is the probability of getting head if the coin is doubly headed coin? So yeah, it is a sure event, right? If something is sure, right, both side head is there, right? So you will always get suppose India versus Australia match is going on, right? And by mistake people have, like, a referee has got what, the coin which is doubly headed. अब वो टॉस किया, तो चाहे आप हेड आएगा, मतलब you can see here, right, head. Okay, both side head is there, so you will say head, you will get head, right? It is a sure event, right? You can say. So sure event की probability क्या होती है? 1. Now if something is doubly, like weighted coin, so what is the probability of getting head? They have given, that is 1 by 3. But what you have to find out here is, as I told you, the probability of getting head is nothing but, according to the total probability theorem. According to total probability theorem, what you have to do, you just take this guy, like you just multiply the branch, you take this and this, 1 by 3 into 1 by 2 plus 1 by 3 into 1 plus 1 by 3 into 1 by 3, right? Means you have to take the initial belief times the conditional probability. Okay, and this will give you the answer. I think many of you might have understood this concept, right? So please remember this. Okay, this is one of the very important concept. Okay, so you see how fast we can find the answer without writing any sort of formula like P given A, P E A given B or something, right? Okay. what is told you what is taught in your classroom, right? So you can avoid those big formulas and you can write the answer quickly. What is the answer here? Can you solve this? The answer will be 11 by 18. 11 by 18 by using total probability, TPT. Okay, so whenever we talk about total probability theorem, we always go for like what will be the probability of getting head. Okay, suppose they are asking what will be the probability of getting tail. Okay, getting tail. So in the same question, suppose they are asking what is the probability of getting tail. Okay, after happening all this, right? So in this case 1 by 2 into 1 by 3, that is fine, plus यहाँ पर 0 आएगा, like 1 by 3 into 0. Why 0? Because you cannot get tail. Okay, if there is a doubly headed coin, right? If there is a doubly headed coin, you can't get tail, right? So that is impossible event. Okay, so probability is gonna be 0, right? So you always take 0, right? And then you can say 1 by 3 into, now you need to find the probability of getting tail here. Okay, that conditional probability. So 1 by 3 is this, right? So 1 minus 1 by 3 means 3 minus 1 by 3, that is 2 by 3. So then you solve it, so you will get probability of tail. I think this is clear. So in this manner you can find out. Okay, now let us see the same question. I'm going to pick up same question. There is no change at all, guys. There is no change at all. That is why I will copy this question from here. Same question I'm going to take, but I will do some little modification, and you have to identify that, yes sir, now we will use what? The Bayes theorem. See, whether you're going to use Bayes theorem or total probability theorem, total probability theorem has to be done first. Okay? Then Bayes theorem will come into picture, right? Same question. Okay, let me remove this guy. Okay, let me remove this guy. What is the question here? Let me read the question first. Okay, so the question says that same question. Okay, so there are 3 events basically in the beginning. Okay, picking up coin, pair coin, weighted coin, as well as doubly headed coin. See, you can also do this solution step by step. Okay, so in step by step, what will happen here is that in step by step, it will take a lot of time, right? You will write all the events. Okay, and then it will take a lot of time. So I would suggest don't write anything. Okay, मतलब इसको अगर आप event से करते हो, same question if you want to write with the help of so suppose this same question you want to do like this. Suppose these are the events E1, right? E2 and then E3. Then you can say that next event has to occur, but that should be E intersection E1, E intersection E2, E intersection E3, right? And that E is nothing but probability of getting head. Right? So you want to get probability of E. Probability of E is nothing but what? Probability of E intersection E1 plus probability of, you have to add all. Okay, these are the common probability that you know, right? Now how to write this? Using conditional concept, right? Using multiplication rule. So you know that this is probability of E1 and this is nothing but probability of E given E1, probability of E2, and then probability of E given E2, probability of E3, so probability of E given E3. See, what we are doing is we are multiplying this and this. Okay, like ordinary probability times the conditional probability, right? In order to get this, in order to get this, in order to get this, and then we are adding. So you don't have to do this much, right? This big formula you don't have to write. Okay, why to write? Just you have to just find out the probability and assign to these branches, and keeping in mind that why you are multiplying, why you are adding, all those things are already discussed in the classroom, right? So please remember that, and everything is free, everything is available as a playlist, so please keep following, spend more time on that. ठीक है, चलो, तो आपको क्या करना है? Let me take the question again. I mean, the same question that I want to talk. Okay. Now, what modification in this case I will do is check. Right. So suppose you have got a question, same question, right? But I will do some sort of a modification. Okay. Some modification I'm gonna do, right? 1 minute. So same question, but I will do some modification, right? Suppose the question is a box contains 3 coins, right? One coin is fair, one coin is two-headed, one coin is weighted, right? A coin is selected at random and tossed. Okay. अब देखो यहाँ conditions आ जाएगी. You just remove this guy and see the changes in the statement, guys. Okay. So that you can identify, yes sir, यहाँ पर हमें base theorem लगाना है. देखो बोल क्या रहा है? If head appears, see, already he has told you if head appears, okay, then you have to revise the initial belief. देखो अब आगे देखते हो, देखो statement. If head appears, right, what is the probability that fair coin was selected? मतलब that head was appeared because of fair coin. Okay. If head appears, what is the probability that it head appears? Find the probability that fair coin was selected. Fair coin was selected. The magic, I think you guys understood, right? Now in this question, see, if they're asking probability of getting head, so you have to use total probability theorem. In this case, what they are saying, now there is a if head appears, that head appears because of what? What is the probability that is because of that guy, right? Because of fair coin, right? So let me again draw the same situation, guys. देखो हमारा जो ट्री डायग्राम रहेगा सेम ही रहेगा, ट्री डायग्राम सेम रहेगा. लेट मी ड्रॉ हियर. देखो we have got 3 coins here, right? From the 1 2 3, right? You can say that I'm just going to pick up these 3 coins. Okay, you can say fair coin, doubly headed coin, and the weighted coin. Now what they are saying that if head appears, you can say, yeah, certainly there will be a head. You can say head appears. Now you just assign all the probabilities, right? तो यहाँ कितना हो जाएगा? 1/3, 1/3, 1/3. Here 1/2. This is 1. This is 1/3, right? Okay. Now what they are saying is they are saying that what is the probability that, right, fair coin was selected, right? What is the probability that fair coin was selected, right? So you have to write like this: probability that fair coin was selected given that head appears. ठीक है. तो इसको कैसे निकालेंगे? You don't have to write any formula here, right? Here total probability of getting head. Okay, so you can say that will be 1/3 into 1/2 plus 1/3 into 1 plus 1/3 into 1/3. The denominator will be the total probability. You know, this denominator can be computed using total probability theorem, right? But what will be the numerator now? The numerator should be this product. Okay. 1/3 into 1/2. That is the answer. Okay, that is the answer, guys. And here I am using what? Here I am using Bayes theorem. Okay, so when you have to use Bayes theorem, when you have to use total probability theorem, that you have to decide, you know, by practicing a lot. You have to understand the logic. Okay, many students do not understand this. ये मैंने देखा है gate. I'm talking about gate aspirants in general. I'm not talking about any other competitive exams, right? So देखो इंडिया में टॉप जो करता है इट्स फाइन, नो डाउट. मतलब आई एम टॉकिंग अबाउट इन जनरल, राइट? So all the population of India, right, who are appearing for GATE exam, right? So this is the problem here, right? Okay, so you have to always see how fast we can answer the question, right? It will not take more than 20 seconds or 10 seconds to solve the question, okay, of any kind. Okay, so if you solve this, you can get the answer, right? What is the answer here, guys? What is the answer? Okay, so you can say that the answer will be 3/11. The answer will be what? 3/11. तो solve करोगे तो कितना आएगा आंसर? 3/11. Now suppose they are saying that if head appears, okay, question आ गया मान लो ऐसा, if head appears, but what is the probability that was doubly headed was selected? I mean the coin was doubly headed. कैसे क्या करोगे? ऊपर क्या मल्टीप्लाई करोगे? 1/3 into 1 एंड नीचे क्या रहेगा आपका टोटल प्रोबेबिलिटी ही रहेगा. ये सपोज दे आर सेइंग दैट वेटेड कॉइन वाज सिलेक्टेड, ओके, एंड हेड अपीयर्स, क्या हो जाएगा ऊपर 1/3 into 1/3 एंड देन टोटल आपका वही रहेगा whatever calculation. You see, there are 3 questions we have done. Okay, you can take 3 questions from single question, right? So I hope this makes sense to you. You don't have to write those formulas like P A given B or something. Okay, that is waste of time, pure waste of time, you know, in the gate examination. In semester exams you have to do everything properly. In, you can say, in IES mains, okay, but you know, as I'm guiding for gate 2024 or future gates, right? So you know, I'm just focusing on you are going to supposed to get into IITs and ISC, right? Okay, that's why I'm guiding. Okay, just to make your life more simple, right? Fine. So I think this is clear, right? Where we have to use Bayes theorem and where we have to use you know, so systematically you can do also. I don't want to write systematically. I can show you systems, right, if you want. Okay, so what is systematic way of approach? Dekho, there are 3 events, okay, E1, E2 and E3. These are the 3 events you can see. Okay, now one of the event is nothing but, here we say that, yeah, the head appears. So E intersection E1, you can say that E intersection E2, okay, E intersection E3, right? Okay, so here the probability of E1 and the probability of E given E1, that is conditional probability, right? Probability of E2. Okay. The moment you know the event, you can assign the probability to that event, right? Please remember this. Now here you can say that probability of E given E2. Okay. Here the probability of E3. Okay. Though I don't recommend this math. I mean, already I have given you one session on this, right? So just to realize that there are few tools like multiplication rule is there, total probability theorem and Bayes theorem. So you can just, how to find that? Just if you want to apply total probability theorem, you have to use what? Conditional probability times the ordinary probability, right? This is nothing but probability of E given E3. This is called conditional probability. You can say CP. This is called ordinary probability, ordinary, simple, right? Probability. Now, if you want to find here what? The probability that E1 or E1 was selected, you can say E1 was happened and you got E. E is nothing but what? E is nothing but probability of getting head, you can say. So this can be written as probability of E1 times the probability of, you know, just multiply these two probability. Okay. In the numerator you put this. Okay. So this is nothing but let me write properly. You see the formula, I'm not thinking, in fact, I'm not thinking while writing the formula. Okay, blindly I'm writing, guys. Okay, just like this, by closing your eyes. Okay, since you have drawn this sequential description, right? So from here to here, one event, and again there will be second conditional event, then, you know. So this is nothing but what? Probability of E given E1, right, times the probability of E1. You see here, this is E1 given E, this is E given E1. Magic, right? And then in the in the numerator you can say addition of all, addition of this, multiplication of this, multiplication of this, multiplication of this. So I'm just going to write probability of E simply, and where probability of E is nothing but total probability theorem से निकाल सकते हो. What you will do? Ordinary times, you know, conditional, ordinary times conditional, ordinary, all the you know, all the possibilities you have to include in total probability, right? But okay, so Bayes theorem is nothing but revising the initial beliefs. So I think this is clear for all. Okay, fine. So let's move ahead and take other problems also. So this is how we apply the total probability theorem and the Bayes theorem, right? Fine. So I'm just going to take one more question, right? This question is nothing but you can say that 1 minute. Yeah. The question is very simple question. Let me take here. Why to write? Why to spend much time? Just we can take the question from here directly. So but this is a question, okay, and we have to find out, okay, we have to see what we have to apply, right? Yeah. So a bag contains, suppose this is question number 3. A bag contains 3 white, 2 black balls, okay. I think many of you might be facing a lot of problem solving this kind of a question, right? Okay. Bag B contains 2 white and 2 black balls. One ball is drawn at random from A and transferred to B. Okay. One ball is selected at random from B and found to be white. What they are saying is found to be white. Okay. Matlab, I hope you understand, right? The probability that the transferred ball is white. The transferred ball is white. This is a very good question. Now you have to identify what you have to apply, whether it is a total probability theorem or a Bayes theorem, right? So question again, let me read. A bag A contains 3 white. Okay, so let me draw the 2 bags. There are 2 bags, you can see. One bag is this, one bag is this. Okay. So these 2 bags are there. You can say 3 white and 2 black, and then 2 white and 2 black. I think this is clear, right? Suppose this is A bag and this is B bag. 2 bags are there. Now what you're doing is one ball is drawn at random from A. So from A you can draw one ball. It can be white or black and transfer to B. Okay, just take one ball and transfer to B. One ball is selected at random from B. Okay, and is found to be white. Okay, so then you have to select. First you have to take out ball from A and transfer to B. So number of ball in B will increase and number of ball in A will decrease, right? Then you have to select from B, right? Okay, and then once after selection you found that that ball is white. Okay, the probability that the transfer ball is white, right, means transfer ball from, you can say, from A to B. Okay. So can somebody tell me whether it is the application of total probability theorem or Bayes theorem? Yes, please recognize that, because I'm going to solve this question in 1 second, right? So you can say that if you're going to pick up the ball, so it can be either white or black. Either white or black, you can. Okay, these are the 2 bags. Okay, so step number 1 will be this. You are going to take first sequence number 1. You can say step number 1. You're going to take one ball, draw one ball from A and transfer to B, and then you have to select. That will be second event, right? That will be second event. See, so in first event, you can take white ball or a black ball. You don't know, right? Either you can take white ball or black balls. Okay. Yeah, because that is the random experiment, right? You are drawing from ball, bag A. So you can either pick up white or black. Okay. What is the probability of picking up white? And what is the probability of picking up black? That you have to decide. Now, after picking up white or black, and then you are keeping inside the bag B, then you select from B. So what you found that after selection, you're selecting, you found that this guy is white only. This guy is white. So what is the question here? Then what they are saying that what is the probability that the transferred ball is white? Matlab, you have to apply the total probability theorem, but you have to get back. So you have to find here the transferred ball is white, you can say, given that white. So this is nothing but a Bayes theorem. Okay, this is nothing but a Bayes theorem. So in this question, what you have to apply is the Bayes theorem. I think this is clear, right? Okay. The transferred ball is white. The transfer ball is white. Okay. So let me apply everything. Just find out the probabilities. Okay. So what is the probability of you can say drawing white? Okay, drawing white from you can say from bag A. So it will be nothing but 3 by 5. Okay, it is nothing but 3 by 5, right? So it will be 2 by 5, you can say, because there are 2 black balls, 2 by 5. These are the probability we have assigned. Now once you have got these probabilities, okay, so you put in this, okay, so okay, suppose you can say one ball has got one white ball, you can say one white ball you have taken and you kept here, so white ball will become how many? 5, right here, sorry, 3, okay, and two black box ball are already there, so you have to select, right? So what is the probability that you are going to select white ball? Okay, so you will get white only, so that is going to be 3 by 5. Why 3 by 5? Because once you have, suppose you are taking a white ball here plus 1 white ball, so this guy will become plus 1, and suppose you are going to take black one, so it will become plus 1, right? So okay, it only one ball has to be transferred, right? So I'm just not going to write like this, okay, you have to understand. One black, right? Suppose one white, so number of white ball will be in the back 2, it is going to be, you can say 3, total ball are 5, so 3 out of 5, right? And then suppose black is there, you have taken black, from you can say box A, okay, then put it back to box B and then select it. Okay, ये कितना हो जाएगा? 3. Okay, so the answer will be 2 by 5, right? Answer is going to be 2 by 5, I think, yeah, because there are 2 white balls only. Okay. So let me write here, this is 2 by 5. Okay. Now you can find out quickly, right? What is the answer here? I think anyone can answer now, right? So the answer will be nothing but what? Let me write. The total probability is nothing but just multiply 3 by 5 and 3 by 5 plus 2 by 5 and 2 by 5, and in the numerator what should be there? What they are saying is the transferred wall is white. Transferred wall is white. Transferred white means you have to just multiply this guy and product put in the numerator. This is the answer for this question. So this question is based on Bayes theorem only, right? I hope this makes sense to you, right? So this is very, very important concept that you guys have to understand, right? And then what you have to do? Yes. So the answer for this question will be what? The answer for this question will be 9 by 13. 9 by 13, okay? So you can solve this. This is 9 by 13. Yeah. So always remember, see, with the help of this small sequential description, right, a small tree diagram, we are able to get the answer very quickly. But if you're going to write everything, right, step by step, so you can say that this is the event number 1, this is the event number 2, and then this is the final event that you can say. We are talking about white, okay? Now you're getting back. If you're coming back, means they are asking probability or that the transferred wall is white, so you're coming back. The answer for this question is D, right? So it doesn't take much time to solve the question. Okay. Now let us take one more problem, right? So these kind of problem, many people face a lot of challenges, but now you will not face any challenge, right? So one more problem I'm just going to bring here in front of you. Suppose this is a problem. Suppose this is a question. So there are 2 bags. The first bag contains 5 white balls and 3 black balls, right? Let me draw here 5 white balls and 3 black balls, right? And second bag contains, you can say that 3 white balls and 5 black balls. Okay. 2 balls are drawn at random from first bag, okay, and are put into second bag, right? Matlab, either you can draw 2 white balls or 2 black balls, right? Okay, or without noting their color. So it can be 2 white, it can be 2 black, and it can be white and black also, right? It can be white and black also. Then 2 balls are drawn from the second bag, okay? Find the probability that the balls drawn are white and black. Find the probability that balls drawn are white and black, right? It is a very good question, you see, okay? It is a very good question. Then 2 balls are drawn from second bag. What you have to find? You have to find the probability that the balls drawn are white or black, white and black, white and black. So in this question, what you have to do? It's a very simple question. You can solve again this question in next, you can say that 20 seconds if you are attending my class, right? ठीक है, तो इसमें क्या हो जाएगा देखो, situation I think you guys understood, right? So you can say that first event is you are going to take two balls from the first A bag and B bag. तो आप बोल सकते हो टू बैग ले सकते हो, मतलब two balls you are drawing means it can be white, okay, or it can be black, or you can say it can be white and black, right? So this is the first event that you have to this will occur. Okay, so this is here you don't have to waste much time, right? Many people face a lot of problem. I don't know why solving box ball problem, right? Now what you have to do, then you have to draw again two balls, right, from here. Okay, again two balls you have to draw from here, right? So I think you guys can find out the probabilities, right? Again two balls. Suppose you are going to choose two balls, right? Both are white. So what is the probability that you can say that there are 5 white balls, right? Total balls are 8, right? So 5c2 upon 8, right? 5c2 by 8. So you can find the probability simply, right? So if you're going to draw the ball, if you're going to draw the ball from second bag, so they are saying that that should be white and black, okay? So what is the question here? This question is based on TPT. This question is based on TPT, guys, right? Okay, after the once you draw the ball from the bag B, okay, so they are saying that that should be white and black, simple. Okay, now so what is the tree diagram here? How to find the probability here, right? So that you have to understand, okay, that you have to understand. So you can say that here you are going to get WB, West Bengal. Now you just find out the probability and multiply, that's it, okay? What is the probability? This 5c2 by 8, you can say that. Now two blacks, matlab 3c2 by 8, 3c2 by 8. Sorry, it should be 1 minute. It should be like 2, you are choosing, right? So you can say that 5c2 by 8c2, right? You need to find the probability here. So 5c2 by 8c2, and here also you have to do like this, okay? So these are the probability that you have to write by yourself, okay, by using some combination concept that you have learned, right? So selection, how you do selection, 5c2 by 8c2. For this you can say that it is going to be 3c2 by 8c2, and then white and black, one white, one black. You can say that 5c1, 3c, you can say 3c1 upon 8c2, right? So I think this is clear how we find out the probabilities, right? Okay, 5c1 into 3c1, this is clear, okay? This branch probability, like initial belief, you can compute quickly. Now you have to compute this conditional probability, right? Okay, so if you have got white, okay, both whites are there, right? So if both whites are there, means here how many white balls are there? Then there are total 5 white balls and 5 black balls are already there. So one black, one white. You can say that 5c1 and then 5c1 only upon, okay, 5c1 and 5c1 upon, you can say that 10c2, right? I think this is clear, because the box B is going to get updated after transferring 2 white balls in the black box B, right? Now suppose 2 black balls has been transferred from A to B, right? So here there will be total 7 black you can say that black balls, right? 7 black balls. So you can say that 3c1 and 7c1 by 10c2 again, okay, because 7 plus 3 total will be 10. Now in this case, suppose white black means only one will get updated. It will be 4, it will be 6. So you can say that 4c1 and 6c1 upon 10c2, right? So this is how we find out the probabilities, right? Branch probabilities. Now what you have to do, you can just multiply. Simple. You can just multiply and add. Okay? Just multiply and add, right? So I'm just going to write this guy. Let me copy from here. Okay, this is very important question, and you see, we are able to solve this question very simply. Only calculation is there. That's it. I mean, little calculation, right? Now what you have to do, you have to find probability of getting black and white, which is equal to 5C2 upon 8AC2 into 5C1 upon 10C2 plus. We are multiplying this and this branch and this branch. Right? So you can say that 3C2 by 8C2 into 7. Okay. This is 3C1, right? Let me check. 3C1. 3C1, 7C1 by 10C2 plus. Okay. Here it will be, 5C1, 3C1 by 8C2 into 4C1, 6C1 by 10C2, right? So just you have to solve it, right? You just solve it and you will get the answer. Right? So, but you don't have to worry about anywhere. Okay? It's a very good concept. Okay. So I just gave you the answer and you guys can just solve it. I think many of you might be familiar with what is 5C2 and 8C2. Just solve this and you will get the answer. So here what we are doing is we are using TPT. Okay, conditional probability as well as total probability theorem as well as multiplication rule, everything is going to be used here. Okay, fine. So let me take one more question. It's a very good question where we can solve this question quickly. So whenever balls problem will be there, then you have to use combination because selection you have to do, right? ये देखो. So two machines are there, right? Two machine A and B produce respectively 60% and 40% of total number of the item of a factory. So 40%. Sometimes probability is also represented using you can say the percentage, right? So you see the percentage of defective output of these machines are respectively 2% and 50%, right? If an item is selected at random, what is the probability that the item is defective and non-defective? Khatam. It's a total probability problem, right? Total probability problem. Okay, so what do you have to do? First of all, there are two machines. One machine is this, one machine is this, right? So they have got 60% and 40%, right, of the total number of items factory. Okay, the percentage of defective output of these are also given like 2% and 5%. Okay, if an item is selected, what is the probability that an item is defective? So you guys can solve this question quickly, right? So just draw the tree diagram and you will get it. Okay. So how to draw that? See, first you will select the machines, right? Okay, if you select the machine, okay, so okay, here I'm gonna use TPT, remember. Okay, so if you choose there are two machines. Okay, so one guy is giving you 60%, 50%. Suppose this is A machine and this is B machine. Okay, so they are going to produce what? The total number of item of a factory, you can say 60%. And okay, so this is the production. Now these machine can produce defective and as well as non-defective. So first of all we have to find for defective, right? So you can say that for defective. Okay, so if A machine has been selected, so what is the probability that it will produce defective item? They have given already 2%. ये दिया है तो इसका 5%, right? Okay, these are the defective probability they have mentioned. Now you have to find probability of defective, right? So it is nothing but 60 by 100 into 2 by 100 plus 40 by 100 into 5 by 100. So all the LCM is gonna be same, and it will be 120 plus 200 by 100, right? Then it is nothing but 320 by 100, which is 0. I think there is some issue here. 1 minute. What is the answer here, guys? I think this is clear. Yeah, it is clear only. But what we have done mistake here is we need to multiply 100 into 100. That is 100. Okay, this kind of thing, like 10,000 you can say. Okay, so I thought otherwise probability will be greater than 1. So that is wrong. Here 120 plus 200, which is 320 by now you can cancel, so you will get here 0. Something 0.023 32, sorry. This is the answer. How fast you have got the answer, right? Okay. Without thinking. So whenever you know these algorithms, right, so you can solve the question very quickly. You don't have to waste your time. You don't have to write the formulas. That is why I encourage everybody to please follow my sessions. Okay, not the sake of my own benefits, for the sake of your benefits. At the end of the day, if you're going to learn, so your near exam is gonna be good, right? Otherwise, again 1 year, because in my case I have been facing the same challenge, right? Suppose this year I got lost, चलो next year तैयारी करते हैं, next year भी गया. देखो, getting 40 marks, 60, 30 marks is not a big deal, right? I mean, not going to get anything in future, right? मतलब आपको स्ट्रगल फिर हमेशा ही रहेगा, ठीक है? If you're going to get more than 60 marks, you got into IITs, placement हो गया, life थोड़ा सही हो गई बस, ठीक है? ठीक है, so that's what I would suggest. And forget about placements, forget about this rank and all. You should know the right method of solving questions, right? You should never waste your time while solving the question. Okay. See, we can tolerate wasting time using Instagram, Facebook, everything, right? But we can't tolerate, if you're solving question and you're wasting your time during the 3 hours of exam. That is very bad. So this is very important. Now, if suppose defective का पूछा है कि non-defective means 1 minus defective बस, है ना? You don't have to, non-defective means what? 1 minus the probability of defective. ठीक है, तो इसका कितना आ जाएगा? 1 minus 0.032 बस, यही आंसर है, ठीक है? So in this case, if they are asking what is the probability of getting non-defective, so use the same tree diagram, find for defective, and then you can subtract. ठीक है? That is very, very important to understand. Okay. Now we will take one more problem where we are going to use Bayes theorem, right? So let's see where we are going to use Bayes theorem. ठीक है? Suppose the same question is there. In a factory which manufactures bolts, machine A, machine B, machine C manufacture respectively 25%, 35%, 40% of the bolt. Of their outputs, 5, 4 and 2% are respectively defective. Okay, a bolt is drawn at random from the product and is found to be defective. तो मतलब आपको लास्ट तक जाना है. You have to, it will produce the product and then defective है. What is the probability that it has been manufactured by machine B? तो ये किसका प्रॉब्लम हो गया? बेस थ्योरम का. ठीक है, तो सीधा सीधा डायग्राम बनाना है, राइट? यू स्टार्ट लाइक दिस. ओके, अंडरस्टूड. You start like this. Okay, so let me draw properly because sometimes tree diagram is like, make like this. ठीक है, suppose this is nothing but A machine, B machine and C machine. इनकी probability दी हुई है, you can say 25%, 35%. Probabilities are also represented using percentage, right? ये 40% हो गया, ठीक है? Now all guys are defective, so you can say defective here and सबकी probability given है. तो इसका probability कितना है? 5%, 4%, 2%, right? Now they are asking that if the guy is defective, I mean the product is defective, you can say. Like a bolt is drawn at a random from the product is defective, right? So what is the probability that it was manufactured by machine B? तो आपको न्यूमरेटर में ये चीज रखना है मल्टीप्लाई करके, मतलब you have to find like this probability of B given you can say that B given the defective, okay, which is nothing but 35 by 100 into 4 by 100 and then total मतलब 25 by 100 into 5 by 100 plus 35. This guy will also be present in the denominator. Remember, whatever the part of denominator you have written in the numerator, right? In case of Bayes theorem, what you do always is from the denominator, the part is written in the numerator, right? That's it. Okay, so this is 35 by 100, 4 by 100 plus, because in the denominator total probability is written, so all the cases you have to follow. So this is 40 by 100 into 2 by 100. So you just solve it, okay, you will get the answer. Okay? So I think this is clear. So you guys can solve this, and this is very simple problem. So it doesn't take much time, that's why I'm telling, right? चलो एक क्वेश्चन और करते हैं, okay? Very simple question. Less time, that's why I'm solving question. Otherwise, I have not solved the question if they waste my time. Okay, you guys can solve it. Now, this question you try, guys. How much time it will take to solve this question? Huh? So you see, in a test, an examinee either guesses, copies, or knows. ये सारा event है आपका. Either see. Suppose any exam is there, right? Gate exam is there. So you have to answer the question, right? So either what you can do, you can guess the answer, you can know the answer, or you can copy also, right? So either guesses, copies, or knows the answer for a multiple choice question having 4 choices, which exactly one is correct, right? So the probability that he makes a guess is 1 by 3. Probability that he copies is 1 by 6. The probability that his answer is correct, okay, given that he copied is 1 by 8. The probability that, see, this is a conditional probability they have given from here to here. This is the conditional probability, right? The probability that he knew the answer given that his answer is correct. He knew the answer given that the answer is correct. Matlab, here we have to use Bayes theorem again. Bayes theorem. Okay, matlab the answer should be correct. Answer should be correct. So what is the probability that he know the answer? Right? So if you know the answer, the probability is going to be 1. That is sure event, right? I mean, certainly it is going to be the correct answer, right? So it's a general sense that you have to use, also common sense, you can say. So in 2 line, you can say that the first event is what? The first event is going to be either you can guess it, or you can copy, or So what is the probability that you can guess? That is 1 by 3. What is the probability that you can copy? That is 1 by 6. Now you have to find what is the probability that you know the answer. So I mean, what will be there? 1 minus 1 by 3 minus 1 by 6, right? You can find out, right? From total, just subtract. Okay? Because this is not given, so you can just do it. So that will be 1 by 2. Now, and then they have said that the answer should be correct. I mean, okay, the answer should be correct only. So here correct. Okay, correct answer. So guess करोगे तो क्या होगा? What will be the answer if you are guessing it? If you are guessing is what will be the correct probability? See, one probability they have already mentioned. The probability that his answer is correct given that he copied. मतलब ये probability आपको conditional probability 1 by 8 is given, right? If you know the probability, right? Sorry, if you know the question, if you know the answer, what is the probability of getting correct answer? If you know the answer, right? That is 1 only. That is 1. So what is the probability of getting the answer correct if you're going to guess? That is nothing but what? It's simple, right? So you guys can just find out, okay? So what will be that? That is going to be 1 by 4. That is going to be 1 by 4, right? So just what you do, add these two guys, 1 plus 8, 1, and then subtract from 1, right? So you will get 1 by 4. अब इतना simple question है तो anybody can find out, right? So what they are asking is, they are asking that the probability that he knew the answer given that it is correct. So you can say that he knew the answer given that it is correct. It is going to be what? आपको क्या करना है यहाँ पर? You have to always just multiply these probabilities, okay? One is ordinary, one is conditional, and put in the numerator for what they are asking probability. So that will be knew the answer मतलब ये 1 by 2 into 1, and नीचे क्या रहेगा 1 by 2 into 1 plus 1 by 3 into 1 by 4 plus 1 by 6 into 1 by 8. This is the answer, right? So this is all from my side, guys, for today. I think you might have understood how do we use the total probability theorem, how do we use Bayes theorem, right? And how quickly you can find the answer, right? Whether it is a gate problem or any kind of problem. So please use of it, okay? And understand the, this tree diagram, okay? The branch probability, okay? What kind of probabilities are there, right? There are two kind of probability. One is ordinary probability, one is conditional probability. But multiplication rule is always used here, right? The multiplication rule we are using, okay, whether we are talking about conditional probability or we are talking about total probability theorem or a Bayes theorem, right? So when you are going to come back, you are going to revise the initial belief, you can say that is nothing but a see, here the answer is correct. Now I want to check how answer is correct, okay? Whether you know the answer. If you know the answer, what is the probability that you know the answer and your answer is correct, right? That is a Bayes theorem, okay? We are just making conclusion कि अच्छा बंदे, मान लो तुम्हारा गेट में रैंक आ गया, you got first rank in India, right? So you can get first rank in 3 different ways, you can say, right? You can guess the answer, you might get first rank. You copy the answer, you might get first rank. You know the answer, you might get first rank, right? Now I will come back after the result. I will say that, oh, he got the answer. What is the probability that he know the answer? Like he was intelligent. ऐसा लोग बोलते हैं ना कि मतलब उसका उस बंदे का रिजल्ट आ गया तो क्या प्रोबेबिलिटी है, मतलब क्या है कि वो इंटेलिजेंट था, ठीक है? ये बेस थ्योरम है, कंक्लूजन लोग निकालना चालू कर देते हैं आपके लाइफ में, ठीक है? तो आप सोचो कि आप कहाँ पर बेस थ्योरम यूज करोगे अपने रियल लाइफ में, बेसियन एनालिसिस का कहाँ यूज करने वाले हो और कहाँ पर क्या, ठीक है? तो थैंक यू सो मच गाइज, विल मीट इन नेक्स्ट सेशन, टेक केयर एंड लेट मी नो हाउ वाज द सेशन, कीप वॉचिंग, राइट?